Hi, good morning. Great to be back in Israel for the third straight year. Thank you to the organizers, Avner, Asaf, and Danny for inviting me to give this talk. So I'm the Chief Data Scientist at O'Reilly. So much of what I'm going to talk about today is informed by a few of the things that we've been doing around big data and AI. And to be honest, lately I've been mostly organizing two big conferences. One is Strata plus Hadoop World, and we have a new event on AI. So I'm going to also infuse this presentation with some metrics from our conferences. But most of the data that you'll see in this presentation comes from these two reports, which I'll provide links to later. So full disclosure, while I'm an O'Reilly employee, I'm also an advisor to many fine startups. Some of them are here in Israel, and organizations. So let me begin by talking a little bit about real time. So we just did an analysis of the big data market, and one of the things we wanted to look at was what's the rate of adoption of big data technologies. So as you can see from this chart, it's no longer just confined to the cool kids of Silicon Valley. You really have a nice distribution across company sizes. So in many ways, actually, the conference I helped organize, Strata, has become the de facto real-time summit. And by that I mean there's many frameworks and communities. They all have their events, but Strata has become an event where they all come together and interact. And much of that interaction actually, I would say, still kind of is at the level of components and frameworks. There's a lot of popular sessions at Strata that talk about architecture, solution architecture. How do you put together these components? But I think that one of the things that we've noticed is that there's a growing number of people who don't exactly fall into the category of data engineers or data architects who want to engage with streaming data. And so the nice thing about these people, so here I'm calling them out explicitly as data scientists, developers, and business users, is they're close to the data. They know analytics. So in many ways, they're the ones who can take real time to advanced analytics, so beyond simple counts and averages. So let me take a quick deep dive into one community I know well. So what I'm about to say will probably apply to all the other communities out there. So in particular, I'm going to talk a little bit about what's happening in Apache Spark around real time. Because Spark, as you know, is one of the more popular platforms these days. So prior to deciding what to do about streaming in Spark version 2.0, the architects and creators of Apache Spark went around and talked to their users. And basically, what they found is users wanted to engage in real time, but the way Spark had structured real time at that point, it was still too complex for data scientists and business users. So they spent most of their time actually figuring out what's the right way to open up real-time analytics to non-data engineers and non-data architects. So within Spark, if you're not a hardcore data engineer, so you're not doing Scala or Java, you're probably interacting with Spark using one of these languages. And you're already familiar with data structures from those languages. So what the developers of Spark decided is they're going to create an API that's very, very similar to what these end users already know, and also extend it to have real-time primitives, for example, event time aggregation, to make it easy for these people to develop more sophisticated analytics. So the long-term plan, so starting with version 2.1, is to really make it dead simple for Spark developers and data scientists to really infuse Spark applications with advanced analytics. So again, the end goal here is to empower users who aren't data engineers or data architects. So intelligence, part 2, something I've been thinking about lately. So we at O'Reilly have been tracking AI. It's definitely on the upswing. We've just commissioned a study on the AR market, and we're starting to see companies outside of the traditional early adopter companies in technology adopt some of these techniques. So there's many ways you can describe an AI system, and I just co-wrote a long essay on the state of artificial intelligence, which is about to come out. And in that essay, we actually use the following dimensions to describe AI. For this presentation, I'm going to go slightly old school and kind of structure what I'm going to talk about using components that an AI system should have, right? So pattern recognition, knowledge, reasoning, and planning. So let's talk briefly about pattern recognition. So many data scientists in the audience are familiar with this simple pipeline, right? So raw data to applying an algorithm. And as many of you know, probably 80% of the time you spend, or maybe even 90%, is actually on data wrangling and feature engineering. And not only that, at the end of that process, most of the features you come up with tend to be handcrafted and fixed. So it takes some work to replicate or vary your features, right? So enter deep learning. So deep learning, among other things, holds the promise of automating some of the steps in this pipeline. It has developed a good reputation for automatically discovering higher level representations and features of your raw data. And there's many reasons why deep learning is popular these days. But in my mind, at the end of the day, it comes down to results. So it has produced state-of-the-art results across multiple domains. We found several hundred companies already engaged in deep learning in various stages. So since we just took one snapshot in time, so here. So since we took only one snapshot in time, we didn't have trend data, right? So, but for that, I just kind of referred to a quote from NVIDIA. But here's the distribution of people who are engaged in deep learning. So as you can see, it tends to be skewed towards larger companies at this point, right? So as I said, we didn't have access to trend data, but you can see from this quote from NVIDIA that growth has been amazing over the last 2 years. But there's no free lunch. So at this point in the evolution of deep learning, I think it still requires some experience and expertise to use these techniques well. We at O'Reilly are committed to changing that. So through our conferences, training, and books and videos, we hope to train the next generation of applied deep learning engineers. So part of the complexity comes from network architecture. When I first started interacting with the experts in this field, the networks tended to be simpler. Nowadays, the network architectures have become much more complex, and it kind of reinforces this reputation of deep learning being somewhat of a black box. Obviously, it makes it less interpretable, less simple. But you know, in most cases, it's producing the most accurate results, right? But I think the key is sometimes people forget that it's not always the case that deep learning produces the most accurate results. Actually, I have I have a hobby of tweeting these papers where some ridiculously simple approach beats deep learning. And one interesting factoid about that actually is many of these papers come from Facebook's AI research group. So it seems like that particular group is much more open to using things beyond deep learning. And obviously, as you guys may know, deep learning at this point, at least in its evolution, still requires, in most cases, access to a lot of labeled data. Having said all of that, as I said, in 2013, when I first started interacting with the leading experts in this field, the community was quite small. You really had to apprentice with the people who were the researchers in this field. So there was a lot of oral tradition that you couldn't glean from the papers. I think fast forward to today, there's a lot more libraries. Particularly TensorFlow has generated so much excitement. But in my mind, if you really wanted to do deep learning right now and do it quickly and easily, I think Datto would be a good option. One, it's dead simple to install. You can do everything through Python and Jupyter notebooks. And also they have a lot of starter kits, notebooks that you can just tweak. So I talked a lot about deep learning, but it's obviously not the only approach out there, as I alluded to earlier. So in fact, a recent survey of AI experts had this interesting result. 1/3 of them said that there are techniques that we don't even know about that will contribute to progress in AI. And already some of these, actually, wait. I'm having a really hard time here. Okay. So there's other approaches. And in our research, we already discovered that I would say less companies than engage with deep learning, but still on the order of a few hundred engage with these other approaches of AI, right? So in particular, just like deep learning, if you move away from the tech sector, the top verticals seem to be common. With all these approaches. It'll be financial services, healthcare, and telco. And so as you remember earlier, deep learning was a bit skewed towards larger companies. So many of these other AI approaches still seem to be, the early adopters seem to be these larger companies. So there will be many building blocks in AI, including hardware. So don't forget about hardware, including Intel hardware. For example, ASICs are going to be, I think, an important component of this. So Google, a few weeks ago, just introduced an ASIC that optimizes TensorFlow. So that's pattern recognition. Let's talk a little bit about knowledge. So we're all familiar with these personal assistants. Right? You ask a question or make a request, it does something for you. So, but beyond parsing your requests, so your request can come in the form of voice or text. All these systems still need to know something, right? So once it successfully interprets your question, it has to have access to a body of knowledge. So a parallel development is these conversational interfaces. So this is a very hot thing in Silicon Valley. Everyone is going apeshit over chatbots. And I think one of the reasons why is this natural business model for these things, right? So CRM and IoT. So, and there's also kind of an interesting trend in the US at least. Most people seem to be satisfied with the number of apps they have, right? So very few people are downloading apps. So I jokingly say that most Americans have discovered that they have all the apps they need to keep up with the Kardashians. So one type of app that people seem to inhabit and spend a lot of time in are these messaging apps. So here's one that I use a lot. WeChat, and inside WeChat are official accounts. So these are accounts maintained by companies. So you can see, fast forward maybe even a year, these Official accounts can become basically conversational interfaces where these companies can use AI to interact with their customers. Bottom line is, these conversational interfaces will need access to knowledge databases and knowledge graphs. So how would you build these knowledge databases? So one idea that many people do is to start with dark data. So this would be unstructured data sources, somehow extract structured information from these dark data sources, and then use those structured data sources, the resulting structured data sources, to power your intelligent applications. And one big source of dark data is the web itself, right? So there's so much video, PDF, a lot of semi-structured and unstructured information buried inside all these web pages. So there's an interesting company in Palo Alto that has done exactly this, right? So it's a 15-person company with really good technical founders and employees. So one of their employees, in fact, created this underrated search engine called GigaBlast. So anyway, this 15-person company has now a structured database that rivals Google, might even exceed Google's knowledge graph and knowledge database. And unlike Google, so Google's knowledge database still uses a lot of humans, right? So they tend to, Diffbot tends to do everything using semi-supervised learning. But Diffbot isn't the only company in this space. I think this is one area in this whole AI stack where there's a lot of opportunity for maybe even developing very narrow vertical knowledge databases. But without knowledge, all these AI applications are pretty much useless. Societal issues. Obviously, these machine intelligence systems, before we deploy, we need to probably weigh the costs and benefits, right? So what's the cost of making a mistake if we deploy these systems? And wherever you sit in the spectrum of pure AI or augmented AI, there will be implications in terms of the economy and job loss, right? So in fact, Tim O'Reilly, our CEO, runs a summit once a year devoted to this topic, right? So the next economy. How will these systems affect the job market? So in closing, real-time intelligence are big topics. So what would be a good way for you to get up to speed in these topics? So this is where my commercial begins. So I'm organizing 2 conferences in September in New York. Strata plus Hadoop World, as I mentioned earlier, has become the de facto real-time summit. And we're launching a new conference on AI. And I'm happy to announce that the AI conference, I'm getting the help of Peter Norvig and Tim O'Reilly. So the program is shaping up to be a very good program. So during the course of my presentation, I cited a bunch of stats and graphs. So here are the reports. They're not quite out yet, but you can sign up. And you'll get notified when they become available, which should be towards the end of June. And that's all I have. So if you have questions, I'll be around most of today.